Yeah, we've been prescription farmers heavily for I'd say the last 25, 30 years. Very, very heavily. You just take your advice and put this on, so many kilos of this, so much spray. We'll just rape it a pillage in the soil, that's all we're doing. We didn't put anything back in. What we put back in was a chemical-based nutrient, and it did nothing. Up to about 10,000 years ago, we were living in harmony in natural systems, hunter-gatherers, and about 10,000 years ago, of course, we started sort of building populations, and that forced us to get into more and more intensive food gathering and, of course, into agriculture in settled communities. Intruding into natural systems, breaking up soils, we could sort of grow more pioneer plants, particularly grain crops. So we humans became very, very proficient at disturbing natural environments to create the niches where these opportunistic plants could grow. So as we cultivated soils, we exposed them to oxygen, we turned them over, and effectively we mineralized the organisms in that soil through oxidation processes to release nutrients, to transfer those nutrients to the plants. It's important to understand that there's more biomass of living microorganisms below the soil than there are living organisms above the soil. And by our agriculture, we effectively have killed those organisms to release those nutrient pools, which is then a key part of their productivity. Now, the story at the whole round is, though, that this is mining, this is extractive nutrient harvesting, and it's not sustainable. And of course, right through history, we've had civilization after civilization collapse once they have completely extracted and exploited their soil resources.
There's a complex life and relationship between the microbes in the soil and around the plants and up through the plants through the atmosphere. This relationship is quite critical to the survival of this forest. The microbes in the soil are predominantly fungi, and we have other microbes including bacteria and yeast, and together they support the life of the trees. The trees are capturing sunlight energy from above us and through photosynthesis making carbohydrates, and they send about 60% of that carbohydrate down through the roots to feed the microbes.
How is it possible that this bioproductive system can grow on these soils? And of course they do that by microorganisms, symbiotic associations on the roots of these rainforest plants, very, very rapidly cycling the nutrients so that one molecule of phosphorus might move through an ecosystem like a rainforest 1,000 times faster than the same phosphorus molecule in an adjacent heathland with the same climate on the same soil, but where these activities aren't enabling that bioproductivity to occur. And so the lesson is, what are the processes, the organisms, what are the factors controlling in this difference in bioproductivities? What has caused that heathland ecology, microbial ecology, effectively to crash and be so reduced? And of course the question for us is, can we look at those rainforests and can we design agricultural ecologies which also use these efficient cycling systems to provide the nutrition and the bioproductivity in our food security and future? With 6.8 billion people on this planet are now extremely proficient, but all around the world we are finding that soils, agricultural soils, are crashing in productivity unless they have got continual committed inputs of oil-based fertiliser, cultivation and biocides. And as the end of oil creates shortages, we are going to have to rapidly move back to biological farming, sustainable farming. And we have to be there with that capacity, because if not, food security and biological degradation will be a very, very major crisis.
Permaculture's a design science that begins with an ethic. It works with natural systems so that the human footprint is a beneficial one rather than a negative footprint. It's a system that leads to absolute abundance and is based in the life sciences, some of the hard sciences, and the ethics that allow a sustainable energy audit for all people.
We've created this ideal environment for the plant to grow in. The roots can go down, they can get down further into the soil, they will be coated in exudates or soil, that's the rhizosphere. Now that is the most active area in the soil where microbes want to live, because guess what? They're getting fed. They're getting fed 30% of the glucose made from photosynthesis are put down into that root zone in the day. Every day they're getting fed. So of course then they're going to supply the plant with the nutrients in the amount and the correct nutrients the plant needs for the day. Now if you have naked roots, what I call them, they have to take up what's in the soil water. And nitrogen is one of the quickest things to be taken up into a plant. So it can exclude other nutrients into the plant. So you begin to get very watery plants, unhealthy plants. So when you look at it at a cellular level, you look at the amino acid, you need the calcium and the nitrogen and the sulfur and everything else in balance. But what we've done in conventional agriculture is to create an imbalance in the carbon and the nitrogen that's going into the plant. So once you start to build healthy cells, then you will build healthy plants. Well, guess what? You have healthy plants, you're not going to be needing insecticides, herbicides, every other side. And what is side? Suicide, genocide. It means to kill. So we need to look at, well, once you get a healthy soil, you don't need to use all those sides.
We are doing everything we can to enhance the biological system. And when you pick up a small germinated root of a new crop and you see exudates around the first 3 or 4 root systems, even after a week's germination, and you see that there's no burning tip from over-nitrogisation in the plant, and it's a healthy looking plant, it's a really great start to anything that's living. Your animals start to have better weight gains, better yields at the end of the day, and it's a much happier system to work under. The wonderful thing about it is that you're doing a natural fertility system from your own district. You're actually building fertility in your own patch.
And the challenge is, how do we get carbon back from the atmosphere into those soils, into these stable humates and glomalin, the stable soil carbon forms. And it can be done very productively, very profitably through soil carbon farming.
We've been prescription farmers for heavily, for I'd say the last 25, 30 years, very, very heavily prescription farmers. I've really noticed probably the last 10 years, we've probably hit a brick wall. You'd get to a stage where, usually more's better. That was fine, we could see it. We used to slash, say, nitrogen, urea-based chemical fertiliser. You'd use it like water, or hundreds and thousands. you'd spread it everywhere, and you did get a result. But like I said, over the last 10 years, it's really, it's hit that brick wall. Like the more we threw at it, we're not getting the result. You have to radically change. You change your ways, and you have to do it in a big way.
Biological farming involves balancing the microbes in the soil and remineralising the soil so that microbes have a basis of delivering nutrients into the plant.
Microbial systems are, generally speaking, in a dynamic balance all the time. In simple terms, symbioses develop. One organism feeds another organism, which feeds another one, which feeds another one. You have a self-perpetuating reaction that can develop. Essentially, microbial balancing seeks to perpetuate and incorporate a system which will fix the problem by itself. There are organisms in the microbial world whose job it is to capture energy. There are organisms whose job it is to capture nitrogen. There are organisms whose job it is to find phosphorus, to do stuff. And they will do it if they're all together and happy. They will do it on their own and they don't need supervision.
You could see a dramatic change in a growing season that you wouldn't really expect. You're not supposed to, because you're thinking it's you doubt yourself when you do it, but to see the result is very encouraging. Naturally, you do see straight up. You see the water retention that you do keep. That critical part of the year around here in October, the rain's coming out, late September, October. You still got moisture in the soil where your trial plots that you haven't treated, they're dry. The ease of application of cultivation, the following season, you're not using as much energy to put the crop in, and cost. And your cost is a big thing. But what is cost if you haven't got your soil right? I'll go back to prescription farming. Well, that was fine. Like, we just, we're just raping and pillaging the soil. That's all we're doing. We didn't put anything back in. What we put back in was a chemical-based nutrient, and it did nothing. All that did was enhance weed growth. And when we turn around the other way, we've found that our soils they're more friable. They're holding the moisture. Farming's just not a you can just go out and do it. You'll go broke if you don't do the right things. But you do have to step. You just do have to step out of the square a little bit too.
He's started on this biological fertiliser, and I've just been noticing the difference between what I do and what he does. We seem to be running out of moisture right at the very end of the year, like at harvest time. We need another inch of rain, we don't get it. His crops seem to hang on better than our crops do. Soil structure even looks better, like you get your hands in the dirt, the dirt just looks healthier. The ground's just, it's chalk and cheese between the two different paddocks, and they're only a road between them, so there's no real soil difference. It's just the biological stuff that he sprays on, which I don't really know what it is or know nothing about. It just seems to be doing a fantastic job, and I'm going to try starting to use it this year for the first year.
My first impressions are it's really kind of almost planet-saving type of activity, with here in Australia with soil moisture retention in the soil. The fact that it's more cost-effective for farmers, that it retains carbon in the soil, just seems almost too good to be true. It's all wins. I'm yet to ask him more questions to find a downside, but I can't see one. In the UK, in Europe, it's got to be a win there too, yeah.
This stuff's good. You just park up there, cam lock it up to your pump it aboard, go down the paddock, and it doesn't hurt nothing. It's friendly.
It means that it's possible to encapsulate in a remote site, so let's say we're in a rural distributor, in a bottle, a process that will happen out in the field when the farmer's not there. So it means that you can build a symbiosis that can be spread across a field and catalyse a reaction out there. Rather than saying that if I want something to happen I have to go and get stuff and put it out there, we can go and get something which makes stuff and put it out there. And that when I say that stuff, I mean there are organisms who capture carbon, microorganisms, not just plants. There are organisms, microorganisms, who go and find phosphorus that's sitting there unavailable and make it available. There are organisms which go and do the same for nitrogen and for calcium. And for a farming circumstance, that means that a condition which gradually reduces the amount of the buffer of soil carbon can be reversed, that the ecosystem can be encouraged to capture carbon rather than to release it. That an ecosystem that currently relies on addition of nitrogen from somebody else, from a fertiliser supplier, can be asked to capture nitrogen. And a similar situation with calcium, that calcium can be made available to plants from a biological perspective. So it means, what it means is that energy that otherwise would have to be added to the farm can be brought to the farm by organisms that do the job for you.
It's a mindset. You know, it's not hard, it's just the mindset. You know, people are used to doing the one thing. You can change, and you change rapidly, and the results are there. Three main reasons we've found that farmers are increasingly coming towards the biological liquid fertilisers are, first and foremost, I suppose, the sheer cost of chemical fertilisers has skyrocketed over the past few years. That's forced farmers to look for an alternative. And hand in hand with that has gone the fact that they've found that there's been a reduce in food quality or a reduce in yield been associated with the use of chemical fertilisers. Secondly, the inability of chemical fertilisers to cope with climate change, and particularly in this part of the world where we're seeing more and more years affected by drought. Farmers are realising the fact that they need to focus on their soil health, and particularly the fact that healthy soils can play a real good part in reducing the effects of drought through holding greater amounts of moisture in the soil if they're properly managed. Phosphorus availability to the plant we use the biological fertilisers trebled. The Brix levels in the plants effectively doubled, went from about 6 up to about 12. The soil carbon levels went up on average 1.4% in that first year. And to put that back into perspective, a 1.4% increase in soil carbon led to the soil being able to retain about an extra 220,000 litres of water per hectare. And that showed through at the end of the year when there was more moisture in the soil, had a direct effect on the yields. And the yields last year went from 1.3 tonnes per hectare, where the farmers were using the traditional chemical fertilisers, up to just about 3.5 tonnes per hectare, where they were using the biological fertilisers.
The most paramount link that I could look at as far as health between plant, mineral and the animal or the end product, the flavour. I've never tasted flavour in our vegetable side of things. The meat is a lot heavier, it's denser by weight, and we've achieved that through some remarkable results, and we know that those results have come back because when we sell our animals over the hook, we know what the yield is compared to with what they've been weighed when they left the farm. In the quality of the animal itself, there's been a calming effect. The animals don't take flight. When the cattle lie down at night, you have to drive around them. They won't get up out of your way. They'll eat for maybe half the day, and the rest of the time they'll be down under a tree somewhere chewing the cud. So they've already filled, their appetite's been met, and now they're processing those minerals that we've been able to balance up. They're not hungry like they used to be. One of the biggest notices I've found in soil health on the farm is the worm activity now on the farm has grown exponentially. Worms in that handful, doesn't matter which ones you pick up, there's always worms in the soil around the potatoes. You can actually see the soil food web in their soil as well. The microbes are working in and around that area. There's a life there as well. The other thing that we see all the time is lady beetles, little ladybugs, and the spiders and things that are so evident. When I first took over the place, it was very chemically grown. The farm was producing produce mainly through a chemical production. The red-legged earth mite, the lucerne flea, everything like that was just overboard. And within 12 months, and I was surprised at how fast it came around. The turnaround, all those animals have disappeared. I never ever sprayed for any bugs whatsoever on the farm since I changed it to biological from the chemical system.
We have to farm organically. We cannot use chemicals or artificial fertilisers. Everybody's done it with good intention, So it's no point in blaming the past, but we're here to care for our land and for the next generation. And there's amazing things going on around the world, all over the world, in biological ways of treating our landscapes and of farming very productively. We have about 12,000 laying hens at the moment. Each flock of 1,000 has a 20-acre paddock, and they graze over that whole paddock. So you can see the principles of them being totally free range. They love to be outside, and they're really basically forest birds, so they'll automatically go inside for shelter at night. They're eating flies and bugs and scratching in the soil and having their dust baths and also having a lot of fun. We cannot say what the chickens are eating out there in the field. They're totally natural, and so we can't define the nutritional value of the eggs by the feed that goes into them. So therefore, we had the eggs themselves tested. We've had them tested by the Australian Testing Authority, the Government Testing Authority, and we found that on all factors we excel, particularly in the omega-3, which is so critical because your body can't make it. That's at nearly double. And of course the customers vote with their feet and their money. It's great to feel and to know that what you're doing is producing a product that there's nothing better on the planet. And it's a great feeling.
We're looking for a general microbial formulation which has inherently in it certain characteristics that might be available when they're needed out in the paddock. Having said that, the farmer says to us, we have such and such a problem. The farmer might be a banana farmer who needs to have calcium in the leaves and the stems of the plant at a certain ratio before the banana plant will make bananas. So they need to have calcium at that certain level. If that calcium is not available in the soil, the plant can't do it, can't produce good bananas. So the banana farmer said to us at one stage, can you produce a formulation that helps our banana plants get calcium when they want it, not just when we put it on? It's very hard to know when they want it. So we developed a mechanism which has a trigger involved that responds to a signal from the plant saying, I need calcium. And there are microorganisms who, when that trigger comes, say, here's calcium, here's calcium, here's calcium, and the plants get it.
A good banana you should be able to eat and enjoy. An average banana is powdery, okay? So the first thing we notice is that our sugar levels in our bananas have definitely risen. The second aspect of that is that a lot of our bananas either have a slightly longer shelf life, up to about 2 to 3 days shelf life extra. And thirdly, that they do have a texture and a flavour quite different from a very inorganically produced banana. Currently, we would be very close to 1.5, 1.7 million cartons for the year. Our objective in our biggest farm will be 1 million cartons plus this year. What we've been able to do using these biologically enhanced fertilizers, we not only are able to maintain plant vigor and health, but in a situation whereby certain paddocks that due to one reason or another that have been slightly neglected, what we have found is that we can come back and pull those paddocks out of the fire, so to speak, in a very, very short period of time. That is a pleasing aspect, where in the past they would tell you if a paddock went backwards, all the biologicals in the world wouldn't be able to fix it. That's not true. We have been able to cut inorganic fertilizers by more than 30%. That's across the board. When we get these improvements in soil conditions, we find that a very costly pest, which is nematodes, we no longer have a problem with nematodes. In fact, in the farms that we have been able to put these programs and the maintenance programs into place, we do not use nematicides at all. In fact, in some of them, we have not used nematicides now for over 7 years. So these are major, very major shifts in farm activity.
When we first were talking to the sugarcane farmers, what was said to us was that essentially they were afraid to pass on the farms to their children because the soil was so poor that they couldn't guarantee they were going to get crops good enough to pay for the mortgage. That's a really specific threat to those farms. As a result, the average age of farmers in the region was above 60, and people have a real social issue building up around that. And the farmers were saying to us consistently, look, we want the soil to be better. We know that we've just raped the soil. We've taken out our income. It's all gone now, and now we've got to pass this on and nobody's going to be able to use it. What can you do to help that? So the challenge for us was to allow the farmers to continue to survive, because if they don't have an income, they can't pay their bank loan off, they just go under. So they have to be able to farm, but at the same time to build the soil so that they can feel more comfortable with it. And that boils down to, can you build biomass and soil carbon into that soil while they're farming?
Being microbes, that's part of it, microbial, so I haven't got a microscope to go find them, but whatever they're doing something out there that the ground's getting the aeration, easier tilling, and I really enjoy when I get visitors come and we go around with the shovel and they have a dig on my farm and walk over the neighbour's place and they go straight back into my place again and have another dig just to prove that that's what the microbes are doing. Whatever they're doing something.
What we're looking at, see that the shovel just goes straight in. In this soil, that's just unbelievable, really. Even though it's very, very wet, what you can see is that the structure of the soil, you judge the quality of it by these types of interspaces and see how that PED formation forms. That's all the way through that soil profile now, which when we started here just was not possible.
Well, if you've got healthy soil, you must have healthier crops. And if you can get the healthier crop, the less inputs, the better farming. So I'm very happy with the results of making less money for the fertiliser company. Catch Cry at the moment's Save the Reef. I've been doing that without even trying. With using the product, it's been really supplementary to my soil health, less runoffs, and all that's just, I'm just plodding along doing it with no dramas. Of course, I'm getting better cane. I'm needing less chemicals to get rid of natural grasses, weeds and that. So everything's just a win-win. We have gone to one particular year there where we really cut back on fertiliser, and we're only using about a quarter of whatever all the neighbours were using. Yes, we didn't grow as good a crop as what our neighbours grew, but our input costs were that much lower than the neighbours that we didn't have to harvest as big a crop to make ends meet, and we still ran in a profit that year, whereas a lot of the neighbours were complaining about running in deficit. Frogs, can't be too bad. I know when it's stored on farm it can get a bit strong to the nose, but that's the microbes doing their natural thing. It just seems to be a lot more comfortable flowing along. Everything just, the cropping seems to be, we don't seem to get big highs or big lows. We seem to get a more average cropping all around. Farmers just can't believe what the soil's doing. I mean, to be honest with you, I can't even believe it. I see it every day and I still sit back and wonder and think how we used to do it, and I'm quite surprised that the soil health has improved, the worm growth, the breakdown of the trash blanket, everything's just win-win-win. I've definitely got more sugar than my neighbours, because when you start talking to your neighbours and they'll tell you how good their sugars are, and you just say, well, yeah, well my sugar was at least half a unit to a unit better than that again, and they stop and they start questioning. It doesn't take much to show a few figures and they'll, oh, right, they're understanding where I'm coming from. And that is the one of the reasons why I am growing that slightly lighter crop. I am getting that extra sugar per hectare rather than tonnes of cane per hectare. And it's overall that's what we're paid on, is the sugar per hectare. I'm only a cane farmer, like I've never really tried growing out any other crop, mainly owing to our weather conditions in the valley. But with the soil health being so well, I believe that I could, if the weather would allow me, I think we could go to other crops with no dramas at all.
Because there's so much heat and moisture, all the carbon gets chewed up really quickly in the soil, so you can't grow carbon. There's a conventional wisdom that would say that. It would say that where it's too hot and wet, you can't build your carbon in your soil.
We've always had plenty of rejects at the end of our packing shed. Well, the idea was thought, well, see what happens if we can turn all that stuff into some sort of liquid fertiliser and what it becomes. The whole thing started from there, and through that we've built machinery that pulverises that sort of material to make it for all the microbes to attach itself to it and break it down and extract all the goodness out that's in there. And it's a very stable product. Like, it doesn't matter whether you can go back and use it in 1 week or 6 months, and it's basically still the same. I mean, we've always been sceptical about different things, different ways of farming and whatever, and probably the biggest thing here is, like, our carbon levels. Like, we got none. They're terrible, so to speak. In the last 3 to 4 years, the carbon level has been steadily increasing, and really in the last 2 years, yeah, we're getting 0.3 to 0.4 increases on a yearly basis now, and it's almost up to 1% carbon, which is still pretty average by any means, but when you come from like 0.1 or 0.2 in your soil, virtually none, up to 0.9 to 1% in a matter of 3 to 4 years, it's very encouraging for us to know that this stuff does really work. Yeah, one of the things that we have noticed, especially with our vine crops like the pumpkins and stuff like that, we seem to be getting really good plant vigour, really high bush, with that 30 to 38% cut in nitrogen. So yeah, it's amazing like that. We didn't think that sort of thing would happen with biology, but it certainly does. Like, it's proved to us that, yeah, no, we're getting good growth in that, and our yields are maintaining. So it's it's all win-win.
Soil has been demonised and considered a peasant activity. It's a dirt cheap situation. The reality is, unless our food is actually from rich, alive, minerally enhanced, nutrient dense origin, and we are in a situation where the production of that food and our general resources and needs is creating extra soil, is enhancing the quality of soil, then we cannot call ourselves civilised.
We have killed that selective interface between the physical and the biological. We have killed those microbial membranes that previously protected us and ensured nutrient balances in our plants, in our animals, and in our food systems.
Probiotic approach was better than an antibiotic approach, because the premise of antibiotics said that you wipe something out. It's becoming brutally obvious now that the premise of something being clean and something being better adapted for our use by virtue of killing something else is a dead-end trail. By trying to knock something out that we thought was bad for us, we also knocked out all of our own protection. And you know, that comes down to a basic understanding that nature that manages risk by diversity.
Sometimes we, the public, have too high an expectation of politicians and public servants. They are there really to respond to us. They're not necessarily there to lead us. The lead must come from us. And there are leaders amongst us, of course, but it needs to come from that level. It's a word lesson versus a world lesson. A word lesson is describing an apple. A world lesson is eating it. So we have to get these people who make the decisions to get them to come and taste the apple. Then they get the emotional feel of it, and then things will happen.
Where a cycle or a dynamic reaction is occurring, you always need to have the organisms that are there at the end of the train also present at the beginning of the train, so that the whole cycle continues. If we don't go back to where we discovered that disinfection and pasteurisation were the way to stay alive, and reinvent that process from there to include the incorporation of all the other things that keep us alive, we're in trouble.
There's one thing on this planet that they're not making much more of at all, and that's land. And in the long run, our food security, our water security, our welfare depends on how well we manage that land for the welfare of not just us but all living things. And it's the actual natural capital value of that land and what we do through our management to enhance it that is really value. That's where the source of value is, but that's where the source of our well-being will come from. We talk about water, we talk about nutrients, we talk about productivity in terms of animals or plants moving off it. But we also have to look at it in terms of the natural capital, long-term resilience, value, the ecosystem services in terms of clean water that is now being produced to other people downstream, the biosequestration of carbon, the production of oxygen, biodiversity. So these are the real values that are created and produced out of this landscape. And as long as we keep on doing that, we have a chance on this planet.
Well, back to that good old healthy soil. If we've got healthy soil, it must be an advantage for the next generation to take over the farm. And I feel a lot happier trying to move on a healthy farm rather than an abused farm.
With this change that we've adopted and the results that we are seeing, it sort of makes us feel that we're more sustainable and environmentally sustainable into the future.
First of all, fix the soil health, and then the wealth will follow. And that's where carbon fits into the cycle. You can trade it now, and so on, but the real trick is the health, is the wealth of the soil. So that's where it's really going to end up. And the carrot for the farmer, the good farmer, he will reap the rewards when he fixes his primary problem, and that's fix the soil, and the rest will fix itself.